Okay, so next topic is factor on which the resistance of the conductor depend. Okay, so before that, I'll just show you. See a resistance and difference between resistor. So, okay, resistance and resistor. Resistor is nothing but it is a device. So see, this is called as resistor. Okay, so resistor is nothing but it is a device which oppose the flow of current. See, for example, if there is a current passing here, passing from this, what it will do? It will oppose the flow of current. Okay, it will not completely oppose. The part of it will be opposed. And the resistance is the property of opposing is called as resistance. So resistance is the property and resistor is the device. Now, see, I'll show you another high resistance and low resistance. See, if I'll take a conductor, this is my conductor. These are nothing but atoms. So, if I'll take a wire, if I'll take a copper wire, it will be having copper atoms. So, now this is an example of high resistance. So, this is an example of high resistance. And if I take a low resistance, so this same wire, okay, for example, these are less atoms now. Okay, we'll assume. So here there are many atoms and here there are less atoms. So as I said, the flow of current, who is making the flow of current? The electrons. Because of the flow of electrons, the current is been moving. So I assume this is my electron now. The electron has to reach from one end to another end. Then only we can say the current is been moved. So during this movement, what will happen? The electron are moving, so it is moving. Okay, it will move. What will happen? It will collide. Again, it will collide. So collide, and then it will reach. So it will take less. It will take more time to reach on the other side because of more number of atoms. High resistance. See, high resistance is nothing but as good as traffic. Okay, so while crossing the road, if there is too much of traffic, too much of vehicles, so what will happen? We will take very much time. We will take more time to reach our destination. But same thing, if there is less traffic, so what will be happen? What will happen? So we will take less time to reach our destination. Similarly, this for low resistance. So this is my electron. So electron, when it has to reach our destination, it will flow. So since there is less atoms, it will reach in quick time. So less resistance, more current. More resistance, less current. Okay. So current and resistance, they are inversely proportional. See, V is equal to IR. So I is equal to what will happen? So V upon R. So see, I is inversely proportional to resistance. So if more number of resistance, so resistance, number of resistance means more atoms. More atoms, more it will take time to reach the end of the conductor. Okay, less resistance, it will take less time and it will reach faster to the end of the conductor. Okay, so this is very important, high resistance and low resistance. Now we will study the factors on which the resistance of the conductor depend. Very important, the factors on which the value of R depend. So it depend upon three values. One is length, area. Okay, the third one we will study further. So first is length and second one is area. So we will see how it depends on the length of the conductor. So if I'll take, say I'll take a conductor. So this will be my length of conductor and this is my area. So it is also called as area of cross section. See, if I take this my marker, this is nothing but, we'll assume this is a wire. So this will become my length. Okay, and this part is called as area, which is also called as width. So we have been given the length and the width of the wire, in short the width of the wire. So we will see how the resistance depends upon length and depends on the area. So first case, so for length, we will do for length now. Now suppose if I take two roads, these are my two roads. One is from Mumbai to Pune and second one is from Mumbai to Kanyakumari. Both have same width. Okay, there is a width. There are two roads which has same width, but the distance is longer. So the from Mumbai to Kanyakumari, the distance is long, and from Mumbai to Pune, the distance is short. So what will happen? From where you will experience more traffic? You will experience the traffic in Mumbai to Kanyakumari road. Why? because length is more, we will observe more number of cars. If more number of cars are there, it will be more traffic. So we can see that if the length increases, so my resistance will also increases. So I can say that resistance is directly proportional to the length of the conductor. So as we have seen, if the length increases, more number of traffic, then the current will take, or vehicle will take more time to reach our destination. So I'll show you one more example. See, if I'll take an atom, if I'll take my wire here, so we will be experiencing few number of atoms. Similarly, if I take a bigger conductor, we will see more number of atoms. More number of atoms, then there will be more number of resistance, and the current will take more time to reach my end of the conductor. Okay, so if you increase the length of the conductor, the resistance will also increase. Now we will see area, how it depends on area. So this is my first equation. Now second one is area. See, if I take two roads, okay, same Mumbai to Pune and again Mumbai to Pune, but what is the difference between two cases? The distance is same now, Mumbai to Pune. Since the distance is same, the only thing, one road is narrow and the other one is wide. So what will happen? So in where we will experience more traffic, we will experience more traffic in this situation. Why? Because the narrow road is very narrow. If we have suppose we have 5 to 6 vehicles, okay, they are moving in this road. So what will happen? So 5 to 6, 1, 2, 3, 4, 5, 6. Okay, so we can see there is lot of traffic. But if there are 6 vehicles in this, one will be moving in this direction, 2, 3, 4, 5. So comparatively, the traffic is less over here. Okay, so if the area of cross section, which is called as area of cross, if the area is more, then the resistance will be less. Okay, so we can say that resistance is inversely proportional to area of cross section. So if more area, then the resistance will be less. So we can say that resistance is 1 by. See, if we have increased the area, then the resistance are less. Okay. Now we will combine these two equation. Now we can write this as R is directly proportional to L and inversely proportional to area. I just combine the both equation. So when we have to remove the directly proportional sign, what I'll put equal, and I'll insert an constant value which is called as rho. Okay, it is a Greek word called as rho. So that rho is called as constant of rationality, or it is also called as electrical resistivity of material of conductor. Electrical, I'll explain you what is rho in detail. Remember, rho is called as electrical resistivity or resistivity of the conductor. So now resistance depend upon three factors now. Earlier I said it is depending upon two factors. One is length and one is area. But now we can see that it depends upon L, A and rho. Okay. See, suppose if I take two wires with same length and same area. Okay. It has same length also, same area also. Still we will be having a different resistance. How we can have a different resistance with two wires having same length and same area? So we can have different resistance only if we are making use of two different wire. One if I make use of nichrome wire and one if I make use of silver wire. So if I make use of two different wires, we can have different resistors even though we have same length and same area. So now resistance, as I said, resistance depends upon three factors. One is length, one is area and one is rho. So now see, if I'll make you show SI unit of rho. So we have to find SI unit of rho. So see, I can write rho is equal to R into A upon L. A will go that side, L will come this side. So now what is the value of SI unit of rho, which is ohm? Area is in meter square, length is in meter. 1 meter will get cancelled, so I'll get ohm meter. So rho is nothing but SI unit of rho is ohm meter. Okay, so now next one is, we will see what is the difference between resistance and resistivity. Okay, so difference between resistance and resistivity. Okay, so resistance and resistivity. So first we'll understand what both are. So resistance is nothing but ability of conductor to oppose current. Okay, so it is an ability to oppose current in the conductor. So it is nothing but it is opposing, stopping, preventing, resisting the current to flow. Okay, so that is nothing but resistance. It now resistance depends upon three factors. One is length, one is area, and one is rho. Rho is nothing but resistivity. So okay, so it is nothing but it. I'll tell you in detail what is rho exactly. And this resistivity depends upon only the material. This is very important. Resistivity depends only on the material. So it is the ability of the material to oppose current. So resistivity is nothing but ability of the conductor, of the material of conductor to oppose current. I'll tell you what it is exactly. So now see, both are opposing current. It's not that resistivity is not opposing current, but resistivity, in short, see, you have to understand that resistivity is nothing but it depends on the material. Whether, say, as I said that the silver, if you take two wires, okay, two wires of same length and same area, when both will have different resistance when they are made up of different wires. One is, for example, nichrome, and the another one is aluminum. Okay, so resistivity is nothing but the ability of the material of the conductor to oppose current. Resistivity does not depend on length and area. Okay, so it does not depend on length and area. It only depends on the material, whether it is silver, whether it is nichrome, whether it is aluminum. You can take length, area, whatever you want to, but it will only see that it is silver or it is aluminum. Then how much is my capacity to resist the current? But if you take resistance, it should depend on length, area, as well as material. Okay, now third one is resistance is denoted as R and it is denoted by rho. SI unit is ohm and resistivity is ohm meter. Okay, so I'll just show you an example. See, silver amongst all the conductors, see, all conductors, all metals are good conductors of electricity. We know that. But someone has to be best, someone has to be least. So now silver is one of the best conductor of electricity because it has the power value of resistivity is 1.6 into 10 raised to minus 8 ohm meter. So 10 raised to minus 8 is very less because power is negative. So if I'll give you two examples, 1.6 into 10 raised to minus 8 or 1.6 into 10 raised to 5, which one is greater? This one is greater because it has power, positive power. See, because it has negative power, the resistivity is very less. So if resistivity is very less, what we can say? We can say that current is more. Less resistivity, more current. More resistivity, less current. Okay, so because the silver has the least resistivity, it is a good conductor because it is allowing good amount of current to pass. So less resistivity, it will allow more current, and it is called as best conductor of electricity. Whereas if I take this example, it has more power. The resistivity is very high resistivity. It will allow less current, and hence it is called as insulators. Okay, so insulators has high resistivity, whereas conductor has least resistivity. Hope you understood.